In this lecture, we will cover up the introductory part of computer networks and the internet. We'll discuss about what is the internet from two perspectives. One is the designer perspective and another one is the user perspective or the application designer perspective. So one will cover in the nut and bolts of the internet, what goes into the internet, what drives the internet, what are all the hardwares which we will use, what kind of a setup would be there which facilitates the communication from one node in the network to another node. And then we will discuss about the service description. In the service description, it will be more about the application designer perspective, how they look at the network, what is network for them. And then we will discuss the protocols which drives the network. So straightway we will dive into the introductory part, that what is internet. So here, as you all know and aware about the term internet, the internet, it is network of the network. So there are several networks in isolation, and those are all connected. But our aim is to connect the node in one network to the node in another network. So how that thing is possible? Uh, for example, there are several companies, there are several institutes, there are several organizations, they have their own LAN network, local area networks. And within local area networks, it is very well possible to communicate from one node to another node within the network. But when one organization node wants to communicate with other organizations node, how that thing is possible? What is that which makes it possible? So that is why internet is called network of the network. That's why somehow all these organizations are connected through other internets, and those other internets are also connected to other internet, and somehow there is a kind of interconnectedness. So that we will discuss here in the internet, that what goes into the internet. So first we will understand it from the software and hardware perspective. So to understand the nut and bolts of the internet, we'll straightway dive into this networking diagram. Here in this networking diagram, as you can see, there is a mobile network where the mobile nodes are connected with cellular tower, and depending on the technology this cellular tower is providing to its mobile user, either 2G, 3G, 4G, 5G, they're all connected to the cellular tower while roaming around here and there, provided they should be in the range of the cellular tower. If they will not be in the range of the cellular tower, the connectivity will not be there. And then this cellular tower is connected to the edge router. And this edge router is connected to some of either the national or global service provider, or the local service provider, residential service provider, regional service provider. It could be anything depending on the availability in your area. So here, this edge router, which is providing connectivity to this mobile network through cellular tower, and there are different technologies that I already mentioned. So this edge router is connected to the national or the global ISPs, and to these national and global ISPs are also interconnected. So it may be possible it is in one autonomous system which is governed by one organization, which is governing this internet services. So these providers are nothing but the organizations who manages the affair of these services. And then these are interconnected, because in isolation, if you are even providing services, so you can't have a monopoly over and around the world. That is not possible. So that's why, depending on their investment, depending on their economics, so they scale up their network. But uh, the end point is, the bottom line is that these all things, these all internet service providers should be well connected. Then only they can provide their services to the end users. So here these are all end users. So end users can be connected to the service providers through access network. So this is one of the access network, mobile access network. This is also called wide area wireless access network, because it is wireless. There you are using radio waves which are connecting wireless mobile devices to this structure. This is called, means inside this cell, this is called the cellular tower, which is connected to the edge router. And the task of edge router is to route all the packets to the national service providers. And then these national service providers, or the internet service providers, regional service providers, or whatever it is, their main job is to provide connectivity, so that whenever there is a request from one end, it should be able to reroute that packet so as to make it reachable towards the destination or to the destination. Likewise, there's a home network. Most of you are behind the home network. So here in the home network, you are connected either through the telephonic network, which is providing you an access to your regional or the local ISPs, or it could be the cable network through which you are connected. It could be the broadband connection which your company is providing. It could be anything. So you must be with some sort of a modem which will convert based on the technology which you will use. So if you are using an access technology, where you're connected through digital subscriber line, so your modem will be different from when you will use the optical fibers, because there the channel is different. So the technology differs based on the channel. If you are using coaxial cable, your modem requirements will be different, which will convert your bits into analog signal, and then that analog signal back to your bits. So that technology will different. Based on your technology, you must be with some sort of a modem, and that modem also incorporates either some sort of a router or switch through which you can connect all your devices, or it could be the wireless router. But all these three things which you can see here, the wireless access point, the router, and the modem, in most of your houses, in your home network, it all comes bundled up only in one device, with sometime only you name it as a router. So one, two, three, these all three things bundled together, and that's we term as a router, that provides you connectivity to your local area network providers, internet service providers. And this is the enterprise network. So enterprise network, if I have to discuss the Manipal network, so there are several LANs within Manipal network. So LAN means anything. So there is one device called switch. So behind switches, so this is one of the switch. Behind this switch, if you will connect this switch with uh, the local PCs, all these PCs or any wireless also. So these all devices come together and comprises a single LAN. So anything which is behind your switch works on layer 2 and all these things we will discuss later on, when we will discuss all the layers from application layer till the physical layer. So here this device, physical device, this is called switch. This works at the data link layer, layer 2, and behind layer 2, all these devices are the part of single LAN. Likewise, here also there is a device um, switch. Behind this switch, whatever comes will be the part of single LAN. So here there are two LANs, one LAN and second LAN. Here in this LAN, you have connected wireless access point with this LAN also, which is providing wireless access to these laptops. These three laptops are connected, and these are also the part of the same LAN. These are also the part of same LAN. So one simple rule, or in which way that even anyone can understand what is LAN, that is called local area network, where the point is that if you are behind switch, then whenever you will message anything, whenever you will generate any data packet, so suppose this device is generating a data packet, and it want to transmit it to some other device, then it will generate it, it will pass it on to this interface. When it will reach this interface, now it has one, two, three, four more interfaces. What this device will do, this device, if it is a hub instead of switch, if it is a hub, then it will retransmit it to all other interfaces except the one on which it has received the packet. So hubs are not intelligent. There is no routing mechanism imbibed or embedded in hubs. Hubs also work at layer 2. The hub's advancement comes in terms of the switches. Switches are little bit intelligent. Once you will send a packet on this interface, then it will realize, it will check for other MAC addresses of that packet where it has to destined, where it has to reach finally. Then based on the destination MAC address, then it will reroute it to the effective concern outgoing interface instead of sending it to all other interfaces. So that is the only uh, distinction in between hubs and switches. So that is the LAN. So anything which is behind hub and switches, that all becomes the part of single LAN, and there uh, the redirections of the packet is based on the physical address, that is called the MAC address. But the moment the packet reaches this router will take decisions of rerouting the packet based on IP addresses. So every device which is the part of big giant internet or the network must have IP address, that is called the logical address. Whereas the MAC address is called the physical address because that is attached to the hardware. If you will change the hardware, then only it will change. Whereas the logical address, IP addresses, which you can change, that is logical address, that is not a permanent address. If your device is holding any IP address today, you can change it tomorrow. Once we will discuss the IP addresses, then we will discuss that how all these things are possible. You must have heard about the DHCP server. So the moment you join the network, DHCP server will assign you certain addresses. But the moment you will leave it, so that address is no more with you. Once again, if you will rejoin, it is not possible. The same address you will get, you may get the different address. So everything we will understand later on once we'll start hitting the network layer. Till now, this is all goes into the designing of networks. So you require networks in isolations. Those require an access. Those isolated network require an access to the big internet, and big internet is nothing but it's a network of the network. So if you're the part of network, either through access network, and you're directly connected to internet service providers, and the job of internet service provider is to provide connectivity. So that goes into the nut and bolts. So these are all the nut and bolts of the internet. Now we'll move ahead to, so I think this is enough to understand from the perspective of designer that what goes into the design of network. You require a network, and then you require some sort of an infrastructure which will provide a connectivity which should be interconnected, and it should be robust enough. So if any one link goes down, you must it should be robust, that you must be able to provide connectivity from some other links. So in through links so when we have to discuss, so that now in the next lecture we'll discuss about uh, we'll discuss regarding the access network, that how through access network you will gain the connectivity through internet service providers which are the part of network core.